There is one rule, so fundamental to car design, that most people never even notice it. Every safe car ever built, from the earliest steel-bodied sedans to the most advanced electric vehicles today, has always relied on a single structural element, a vertical pillar, sitting quietly between the front and rear doors. The B-pillar, remove it, and the entire side structure of the car is supposed to collapse. Crash safety fails, rigidity disappears, survival space is compromised. At least, that's what a century of automotive engineering has taught us. And yet a new vehicle from Geely's premium brand, the Zeekr Mix, is attempting to do exactly that. No fixed B-pillar, a completely open side profile, a structure that, on paper, should not work. So the question is no longer whether this design is radical. The real question is, has the industry been solving safety the wrong way all along? To understand why removing the B-pillar feels almost heretical, you first have to understand what it actually does. Because this isn't just a piece of metal between two doors. It is the spine of the car's side structure. In a modern vehicle, the body is not just a shell. It is a carefully engineered safety cage. A network of load-bearing elements designed to do one thing above all else: protect the occupants when everything else fails. And within that system, the B-pillar plays a critical role. Positioned between the front and rear doors, it connects the roof to the floor through one continuous vertical structure. In engineering terms, it acts as a primary load path. When a car is hit from the side, which is one of the most dangerous types of collisions, there is almost no space to absorb energy. No engine bay, no long crumple zone, just a thin door, and whatever structure sits behind it. This is where the B-pillar comes in. It absorbs impact forces. It redistributes loads into the roof and the floor. And most importantly, it helps maintain something called survival space. That small, invisible volume around passengers that must not collapse, no matter how violent the crash is. But this wasn't always the case. Early cars didn't have strong pillars at all. They were essentially mechanical carriages with thin metal skins. And in side impacts, they performed disastrously. It wasn't until the late 20th century, with the introduction of stricter crash regulations, that manufacturers began reinforcing the body structure. High-strength steel was introduced, then ultra-high-strength steel, then complex multi-phase alloys designed to behave differently under stress. And gradually, the modern safety cage was born. Companies like Toyota refined the concept of controlled deformation. Others, like Volvo, made side impact protection a core philosophy. Reinforced pillars, side impact beams, energy-absorbing door structures, all built around one assumption. If you want to protect the passenger, you need a strong vertical column in the middle of the car, and for decades, that assumption held true. Because from a physics standpoint, it makes perfect sense. A vertical pillar is the shortest path between the roof and the floor, and in structural engineering, the shortest path is often the strongest. So over time, the B-pillar became something more than just a component. It became a rule, an unwritten law of automotive design, one that no serious production vehicle dared to break, until now. Because what if that pillar wasn't a necessity, but a limitation? If the B-pillar is so essential, then removing it shouldn't just be difficult, it should be impossible. And to understand why, you have to look at what actually happens during a side impact. Unlike a frontal crash where the engine bay and crumple zones have space to absorb energy, a side collision is brutally direct. The distance between the point of impact and the passenger's body is often less than 30 centimeters, sometimes less. There is no time, no space, no forgiveness, just force. moving laterally into the cabin. The physics problem. In a side impact, energy travels in a straight line, from the point of collision, through the door, into the structure, and, ultimately, toward the occupants. This is called intrusion, and it is one of the most dangerous failure modes in automotive safety, because once the structure collapses inward, the passenger compartment shrinks, and when survival space disappears, injuries become inevitable. The job of the vehicle structure is not just to absorb energy. It is to redirect it, to take that lateral force, and spread it across multiple load paths, into the roof rails, down into the floor, across the chassis, so that no single point takes the full impact. And this is exactly where the B-pillar excels. It acts like a vertical bridge support, a rigid column that intercepts the force and channels it away from the cabin. The traditional solution. For decades, engineers approached this problem the same way. If side impact is dangerous, then reinforce the side, make it stronger, make it stiffer, make it harder to deform. So the B-pillar evolved, from simple steel sections into ultra-high-strength structural components. In some modern vehicles, the B-pillar is made from hot-stamped boron steel materials so strong they can withstand enormous loads without bending. It is welded directly into the body structure, connected to the roof cross members, anchored into reinforced floor sections, and often integrated with side airbags, seatbelt mounting points, structural reinforcements in the doors. In many ways, the B-pillar is not just a structural element. It is the anchor point of the entire safety system. The hidden limitation. But this approach comes with a cost, because while the B-pillar makes the car stronger, it also makes the design more rigid, more constrained. Think about the interior of a typical car. That vertical pillar in the middle, it breaks the cabin into separate zones, front and rear, driver and passenger. It limits door size. It restricts entry and exit. It defines how space can be used. And, in an era where vehicles are no longer just machines, but evolving into mobile living spaces, this becomes a problem. Electric vehicles, autonomous systems, new interior concepts, they all demand something different. More openness, more flexibility, more space. But the B-pillar stands in the way, literally. So engineers face a paradox. The very structure that protects passengers is also preventing the next evolution of vehicle design. And this leads to a dangerous question. Not just, can we remove it? But, what happens if we try? Because the moment you eliminate the B-pillar, you don't just lose a component, you lose the primary load path of the entire side structure. Now the forces have nowhere obvious to go. No central column to absorb impact, no direct path between roof and floor. Which means, in a traditional architecture, the structure collapses. The cabin deforms, and safety is compromised. So for over a century, the industry didn't even attempt it, because from an engineering perspective, removing the B-pillar isn't an optimization, it's a structural failure, unless you redesign the entire system from the ground up. Because this is where the story changes, not gradually, not incrementally, but fundamentally. The Zeekr Mix does not try to reinforce the B-pillar. It doesn't make it stronger. It doesn't redesign it. It removes it. At first glance, this looks like a design decision, aesthetic, futuristic, maybe even impractical, but underneath, it is something else entirely. This is not about removing a component. It is about redefining what structure means. A different philosophy. Traditional cars are built around points of strength. You reinforce specific areas like the B-pillar to handle extreme loads. But the Zeekr mix follows a different idea. What if strength didn't come from one place, but from everywhere? Instead of a single vertical column, the structure becomes distributed, a network of load paths that spread forces across the entire vehicle body. In other words, the pillar doesn't disappear, it dissolves. Load paths, reimagined. In a side impact, force still enters through the door. That hasn't changed. But what happens next is completely different. Instead of being stopped by a central pillar, the energy is redirected outward into reinforced door beams, downward into the floor structure across the chassis, into the opposite side. The car behaves less like a frame and more like a structural web, where no single element carries the full load. The battery becomes structure. This is where electric vehicle architecture changes everything. Because in traditional cars, the floor is mostly empty space. But in modern EVs, especially those using cell-to-body integration, the battery is no longer just an energy source. It becomes a structural component, a large, flat, rigid mass spanning the entire floor of the vehicle. And that changes the physics. Instead of relying on vertical pillars, the car now has a massive horizontal structure capable of distributing loads across a much wider area. Companies like Tesla have already explored this idea with structural battery packs. But in vehicles like the Zeekr Mix, this concept goes even further. The floor is no longer passive, it is active, load-bearing, reinforced, integrated. Doors that carry, load. Then there are the doors. In a traditional vehicle, doors are weak points. They are designed to absorb some energy, but they are not primary structural elements. Here, that assumption is challenged. The Zeekr Mix uses large sliding doors, but these are not just access panels. They are engineered with reinforced internal beams, multi-layer materials, high-strength structural frames. When closed, they don't just seal the cabin, they become part of the load path, which means the missing B-pillar is partially replaced by structural elements embedded in the doors themselves. Material science, the invisible layer. None of this would be possible without advances in materials. Ultra-high-strength steel, aluminum alloys, composite reinforcements, materials engineered not just for strength, but for how they deform under stress. Some sections are designed to remain rigid, others are designed to collapse in controlled ways. Because safety is not about resisting force, it's about managing it. A system, not a component. And this is the key idea. Traditional engineering solves problems locally. Reinforce this point, strengthen that area. But this new approach solves the problem globally. The entire vehicle becomes a coordinated system. Where the floor carries load, the doors share impact, the roof redistributes force. The structure works as a whole. So when the B-pillar disappears, the system doesn't fail, because the responsibility it once held has been distributed everywhere else. And this is where everything changes. Because if safety no longer depends on a single structure, then the rules of vehicle design are no longer fixed. What makes this shift so significant is not just what it changes inside one vehicle, it's what it challenges across the entire industry. For decades, manufacturers like Toyota and Volkswagen have followed a similar philosophy. Reinforce critical nakat, build stronger pillars, create rigid safety cages, and it works. These vehicles pass some of the most demanding crash tests in the world, but they are also built around assumptions that may no longer be absolute. Then came Tesla. Not with a pillarless design, but with something just as disruptive. The idea that the battery itself could become part of the structure. This was already a shift. from component-based engineering to system-level integration. But now, companies like Geely are pushing that idea further. Instead of just reinforcing the existing architecture, they are questioning it entirely. Not how do we make the pillar stronger, but what if we don't need it at all? And that question carries enormous implications. Because if this approach proves viable, it could unlock entirely new vehicle designs. Fully open cabins, modular interiors, seamless entry and exit vehicles that feel less like machines and more like spaces. It could also redefine how safety is engineered, from rigid structures to adaptive systems. But it also introduces risk, because distributing load is far more complex than concentrating it. Failure is no longer localized. If the system fails, it fails everywhere. So the real question is not whether this design is possible. It clearly is. The real question is, does this change the rules of the industry, or does it expose the limits of pushing engineering too far? For over a century, the automobile followed a set of unwritten rules, rules shaped by physics, by materials, by the limits of engineering at the time. The B-pillar was one of those rules, a quiet, invisible structure that carried the weight of safety on its shoulders. And for decades, no one questioned it, because it worked. But innovation rarely comes from improving what already works. It comes from asking a different question, not how do we make this stronger, but what if we don't need it at all? The Zeekr Mix is not just a new vehicle, it is a statement that structure can be reimagined, that safety can be distributed, that the rules of the past are not permanent. And maybe the future of the automobile is not about building stronger machines, but about designing smarter systems. Because when structure becomes invisible, space becomes possible. And when space becomes the priority, the car stops being just a vehicle. It becomes something else entirely, and that may be the real disruption.